Okay, let's unpack this. You know that moment in a sci-fi flick where someone reaches out and manipulates a glowing hologram in midair?
Oh, yeah, totally. Always looks incredibly cool.
It always felt like pure fantasy, didn't it? Something, impossibly distant.
Well, maybe not so distant anymore.
Get ready, because that feeling might just be about to change. We're taking a deep dive into some really groundbreaking work happening right now.
This is coming out of the Public University of Navarra in Spain, UPNA.
And what's so fascinating here, and you touched on this, is that it isn't just some minor tweak to display tech we already have.
No, not at all. There's a whole team of researchers, Dr. Ulrich Busbib, Ayusin Sarasate, Unai Fernandez, Manuel Lopez Amo, Ivan Fernandez, Inigo Escurdia, and Asier Marzo. Quite a few people involved.
All connected with their Institute of Smart Cities.
And they've achieved something genuinely new. A 3D mid-air display you can actually, touch, interact with naturally.
Exactly. We're talking about true 3D graphics, the kind that just appear suspended right there in front of you.
Viewable from all sides, crucially, without needing any special glasses or headsets.
Right. Dr. Busbib described it as moving towards a kind of come and interact paradigm for visuals.
Which is a great way to put it.
So our goal in this deep dive is to really get under the hood, understand the clever science behind this.
Figure out how it's different from current 3D tech.
Yeah, and explore what truly exciting possibilities this opens up for, how we interact with the digital world.
It's definitely worth framing this first, though. We should probably acknowledge that volumetric displays themselves.
The ones where graphics occupy a 3D space.
Right. Those aren't entirely a new concept. There are companies out there like Voxon Photonics, Brightvox Inc., doing commercial work.
Okay, so they exist. But what's the big deal with this new research then?
The key difference, the real breakthrough from this UPNA team is that crucial element, direct physical interaction.
Right. And when Asier Marzo talks about direct interaction, he paints a perfect picture, doesn't he?
He does. The ability to literally insert our hands to grab and drag virtual objects.
Which sounds simple, but think about how intuitive that is, like how you just naturally tap and swipe on your phone screen.
Exactly. They're aiming for that same intuitive level of engagement, that seamlessness.
But with 3D images just floating there, it taps into how we already, perceive and handle things in the real three-dimensional world.
So, okay, the big question, how do they actually do it? How does it work?
Yeah, what's the tech?
Well, the core of their system involves a rapidly vibrating elastic sheet. They call it a diffuser.
Okay, an elastic sheet vibrating fast.
Very fast. And then projectors beam images onto this diffuser at an incredibly high rate. We're talking 2,880 individual images every single second.
Whoa, okay, 2,880 frames a second. That's a lot.
It is an absolute blur of images. And this rapid projection, combined with something called persistence of vision.
Yeah, that's the thing where our eyes kind of blend fast images together, right? Like a movie.
Precisely. Your brain smooths it all out. A movie is just a still frames shown quickly, but we perceive continuous motion.
So this display does something similar, but creates a volume.
Exactly, but in 3 dimensions, creating the perception of a solid, complete volume floating in space.
Okay, that makes sense conceptually. A super fast vibrating screen tricking our eyes.
Uh-huh.
But then you mentioned reaching out to touch it.
Yes.
That seems like where things could get a little dicey with a normal screen moving that fast.
You've hit the nail on the head. That was a core problem. The research team highlighted this traditional volumetric displays often used rigid diffusers, hard surfaces.
And if you accidentally stick your hand through something hard that's oscillating really fast.
Yeah, there's a real risk of damage. To the equipment, obviously, but more importantly, potential injury to the user.
Ouch. Definitely not ideal for what they call natural interaction.
Yeah.
So how did they get around that? Force fields.
Not quite that sci-fi. It was more material science. After experimenting with different things, they made a really crucial switch. They replaced the rigid diffuser with one made of elastic material, like a stretchy sheet.
Ah, okay. So it's soft, it gives way, safe to touch.
Exactly. Makes it safe to physically poke and prod. But this introduced a whole new challenge.
Oh.
What now?
Well, as Dr. Busbib explained, when you touch something elastic, what happens?
Stretches, deforms, bends out of shape.
Right. And that deformation would naturally distort the image being projected onto it.
Ah, I see. So you could poke the hologram, but it would wobble and look all weird and unstable?
Precisely. Which kind of defeats the purpose if you want a stable, interactive 3D image you can manipulate accurately.
So you fix the safety problem, but create an image stability problem. How did they solve that?
This is where the really clever computation comes in. The team had to develop some pretty sophisticated image correction techniques, algorithms.
Okay, so software fixes it.
Essentially, yeah. These algorithms work in real time, constantly calculating and adjusting the projected image to compensate for how the elastic diffuser is deforming as you touch it. Wow. So it pre-distorts the image in just the right way so that when it hits the stretched screen, it looks correct to your eye.
That's a good way to think about it.
Yeah.
It ensures the virtual object stays looking stable and visually accurate, even while you're physically interacting with the screen it's projected on.
Okay, this is where the cool factor really ramps up. What kind of interactions are we actually talking about here? What can you do?
Well, the researchers gave some really great tangible examples. Picture this. Being able to grasp a virtual cube between your thumb and index finger.
It's just like pinching something small.
Exactly, and then rotating it in midair just as you would a physical block.
Okay, that level of control, that intuitive manipulation with no gloves, no controllers, that's pretty remarkable.
It really is. Or another example they gave.
Yeah.
Simulating walking legs on a surface just by using your fingers directly on the display area.
Huh. That really shows the potential for fine-grained control, doesn't it?
Yeah.
It feels like it moves beyond just seeing a 3D image.
To actually physically engaging with that digital object in a very direct, very intuitive way.
Okay, so the tech is impressive. The interaction sounds amazing. Where could this actually be used? What are the applications?
The team outlined several key areas where they see this technology being potentially transformative. Education is a big one.
How so?
Imagine students being able to visualize complex things like maybe the parts of an engine.
Okay.
And not just see it, but actually reach in, assemble the parts, manipulate each component with their own hands as if it were real.
That would completely change hands-on learning, wouldn't it?
Yeah.
Forget static diagrams in a book.
Absolutely. You're interacting directly with the subject matter in 3D space.
What else?
Collaborative work. Think about teams working on a design, maybe an architectural model or product prototype.
Yeah.
They could all interact with the same virtual 3D model simultaneously right there in the room without needing individual VR headsets.
Ah, that's a big plus. VR headsets can be isolating sometimes. This sounds much more shared, natural.
Exactly. Fostering a more natural shared experience, whether they're in the same room or even collaborating remotely on the same display.
Any other examples?
They also highlighted museums. Imagine interactive exhibits where visitors could directly engage with, say, historical artifacts.
Like reaching out and rotating a virtual scan of an ancient pot.
Precisely. Or maybe exploring layers of a painting, bringing things to life in a totally new, immersive way rather than just looking at them behind glass.
It's like stepping into it, not just observing. Okay, this is all really exciting stuff. For anyone wanting the deep technical details.
Right. There's the research paper. It's titled FlexiVol, a volumetric display with an elastic diffuser to enable reach-through interaction.
Published in 2025, and it's available, I think you mentioned, on HAL. We can probably find the DOI if people want to look it up.
Yeah, we can definitely make that available. It's worth noting, too, the funding behind this. This wasn't just a small side project.
Significant backing.
Definitely. The Unveils project, which is led by UPNA, got substantial support from the European Research Council. That's under the H2020 Excellent Science and Horizon Europe programs.
Okay, so major European research funding. That really underlines the perceived potential here.
It does. That level of investment suggests they see this as a potentially significant innovation in the field.
And the team isn't just keeping this in the lab, right? They're presenting it soon.
That's right. They're actually set to share their findings very soon at the CHI 2025 conference.
CHI. That's the big one for human-computer interaction, isn't it?
It is, yeah. It's happening in Yokohama, Japan, end of April, early May. It's a major international venue.
Lots of researchers, industry people.
Absolutely. Expected attendance is over 4,000 researchers, plus you get participation from all the big tech players. Microsoft, Meta, Apple, Adobe. They'll all be there.
So presenting this work there will likely generate quite a bit of buzz. A good chance for these companies to see the cutting edge firsthand.
Definitely a key opportunity. And for those of you listening who are more visual learners,
always helpful, this kind of thing.
There's also a summary video out there. It's on YouTube, credited to Inigo Escurdia from this year, 2025.
Worth searching for.
Mm-hmm.
Sometimes seeing it in action really helps solidify how it works.
Absolutely. Seeing is believing, especially with novel display tech.
So just to kind of wrap our heads around this, what we've really explored here is a pretty significant step forward in 3D displays.
Yeah, the core innovation, that elastic diffuser, seems to be the key. The thing that finally unlocks natural, reach-through-hand interaction with genuine 3D graphics.
It really bridges that gap, doesn't it?
Yeah.
Between just passively looking at a 3D image.
And actively manipulating it in a way that feels intuitive, almost like handling a real object.
And the potential impact, the ripple effects across fields like education, collaboration, museums, it feels huge.
It does, mainly because it leverages something so fundamental, our innate human ability to interact with the physical world.
Which maybe leads us to a final thought, something for you, our listeners, to chew on.
Yeah, this raises a really interesting question, I think. How might this kind of technology, this intuitive, interactive 3D, how might it fundamentally reshape our relationship with digital information?
And maybe even our relationship with the physical world itself going forward.
Exactly. Beyond the immediate applications we talked about, what are the broader implications? What happens when we can reach into and manipulate virtual objects as if they were, tangibly present?
It feels like a profound shift in how we might interface with technology in the future.
It really does. The possibilities there.
Yeah.
Definitely worth contemplating.